Hello everyone, welcome back to the Pixel Developer. In this video, we're going to learn how to use WorkManager in Android to run background tasks using a one-time work request. Imagine you want to run a task just once, such as uploading a file, syncing data, or logging the current time, even if the app is closed or the device restarts. That's exactly where WorkManager comes into play. Here's what we'll cover in this video. We'll create a custom worker that prints the current time and simulates a short delay. We'll trigger the worker from our main activity. Finally, we'll observe and log the state of the worker in real time using live data. By the end of this video, you'll have a clear understanding of how OneTimeWorkRequest works and how to track the status of background tasks with WorkManager. Let's get started. First, add the WorkManager runtime dependency to your app-level build.gradle file by including implementation androidx.work.workruntime 2.9.0 and syncing the project. Next, create a class named SampleWorker that extends the worker class, which is the core component of WorkManager used to define background tasks. The constructor of this class takes two parameters: context, which is the application context, and worker parameters, which contains information about the work request. After setting up the class, override the doWork method. This is where you define the actual logic of the task. The doWork method runs on a background thread managed by WorkManager, allowing you to perform operations like data syncing, file uploading, or logging without blocking the main thread. In this code snippet, we're logging the current date and time when the doWork method runs to demonstrate when the background task is executed. First, we retrieve the current timestamp using system.currentTimeMillis, then format it into a readable datetime string using simple date format. This formatted time is printed to the log with the tag SampleWorker to help track execution in logcat. After logging, we simulate a short delay by pausing the thread for 2 seconds using thread.sleep2000, which mimics a time-consuming task. Finally, the method returns result.success, indicating that the background work completed successfully. In this code, we start by creating a one-time work request for a worker class called CounterWorker using OneTimeWorkRequest Builder, which defines a task to run only once. We then enqueue this request using WorkManager.getInstance, this. enqueue OneTimeWorkRequest, which schedules the work to be executed. To monitor the status of the work, we observe its live data using getWorkInfoByIdLiveData, OneTimeWorkRequest.id. Inside the observer, we check the current workinfo state and log different messages based on whether the task is in queued, running, succeeded, failed, canceled, or blocked. This step-by-step setup allows us to trigger background work and track its progress or outcome in real time through Logcat. Now let's run the app. You'll notice that everything is working as expected. The WorkManager runs our background task, prints the timestamp in the logs, and the log messages clearly show each state transition, from unqueued to running, and finally to succeeded. This confirms that our OneTimeWorkRequest is functioning properly. In addition to our own log, feel free to enhance your worker logic with more useful actions like syncing data, uploading logs, or even showing notifications in the future. App inspection in Android Studio, specifically the WorkManager Inspector, allows you to monitor the status of background tasks in real time. It provides a visual representation of tasks like our OneTimeWorkRequest, showing their states, e.g., enqueued, running, succeeded. This tool is valuable for debugging and troubleshooting, as it helps track errors, work transitions, and execution progress without needing additional log statements. Using it, you can optimize background tasks by ensuring they run efficiently and handle failures appropriately. In our project, it allows us to easily verify that the worker executes as expected and quickly identify any issues. Our next stop is the final and most interesting part of using OneTimeWorkRequest. We're going to simulate a periodic work manager using just a OneTimeWorkRequest. Instead of relying on Android's built-in periodic work request, which has a 15-minute minimum interval, we're going to chain one-time requests manually to run tasks at custom intervals like 5 seconds. Let's take a look at the code and break it down. Now we're going to create a class called CounterWorker, which extends the worker class from Android's WorkManager. This is where the core background logic will reside. Each time this worker runs, it checks for a key named counter value in the input data. If the key isn't found, such as on the first run, it defaults the counter to 0. The current counter value is then logged to Logcat so you can track how many times the worker has executed. This block of code is meant to be added in your main activity to start the chain of background work. It creates an initial one-time work request for the counter worker, passing in an input value of 0 for the counter value key, which represents the starting point of the counter. The WorkManager.get instance, this. enqueue, initial work request. Line then enqueues this request, which triggers the first execution of counter worker. From there, the worker will take over and continue scheduling itself repeatedly with an incremented counter value. Next, we manually schedule the next worker. To do this, we call a helper function called createNextWorkRequest and pass in counter +1. This function creates and enqueues the next one-time work request, forming a chain where each worker triggers the next, effectively creating a loop of scheduled background tasks. We log the counter again for visibility, and finally, we return result.success to inform WorkManager that the current task has completed successfully. This function, createNextWorkRequest, builds and returns a new OneTimeWorkRequest for the counterWorker class. It first creates input data containing the incremented counter value, next counter value, using a data builder. This allows the next worker in the chain to receive and continue counting from where the last one left off. Then it uses OneTimeWorkRequest builder to configure the next worker, setting the input data and adding a 5-second delay before execution using setInitialDelay. Finally, it returns the fully configured work request, ready to be enqueued. All right, now let's run the app. As soon as it starts, open Logcat and you'll begin to see logs from CounterWorker showing the current counter value. The counter will start from 0 and keep incrementing by 1 every 5 seconds, just as we designed it. This means we've successfully implemented our custom version of a periodic task using OneTimeWorkRequest and WorkManager. By manually chaining one-time work requests and passing updated input data each time, we created a flexible and dynamic loop that mimics periodic work request, but with more control and shorter intervals. This approach is great for scenarios where you want to repeat a task more frequently than the 15-minute limit imposed by Android's built-in periodic work request. With that, we've reached the end of this WorkManager mini-series. If you're interested in using the official periodic work request for battery-optimized background tasks, I've already uploaded a separate video on that. You'll find the link in the description below. Make sure to check it out to learn more about proper periodic background processing in Android. Alright, that's a wrap for this video. I hope you found it helpful. The complete source code is available on GitHub. You can find the link in the description below. If you enjoyed the video, don't forget to like and comment your thoughts or any questions you have. Make sure to subscribe to the channel and hit the notification bell so you never miss an update. And hey, follow us on Instagram for more updates, behind-the-scenes content, and coding tips. Thanks for watching, keep coding, and I'll see you in the next one. Happy coding!